Yeah, good morning. Good morning, everyone. Good morning. Yeah, let's start now. I think everything is ready. This is the place where we stopped in the last class. In the last class, we stopped here. Right? This is the last problem. Let me start today's session. Let me start the today's session. So, what is the today's date? Let me check the date. I think 2. Today's date is 2 5 26. 2 5 26. Right? Let me start the problem. This is the place where we stopped. Right now I am giving the next problem, which will be really contain some more new things. So the topic of what is going on is list. On the list we done the approximately 3 or 4 problems. Now can you see the next one? Can you see the next one time? So I am writing now. M is equal to 87, 64, 33, 95, 7, 6, 78, 7, 6, 78, 80, 68. M is equal to next one. Print 1 comma M. Remember that 1, 2 numbers, whatever I am giving for our comfortability. Print 2 comma ID marks. Next one. Marks in the sense M. ID of M. For shortcut I written the M. In notes I written marks. Yeah, shortcut I am writing marks. Actually M is a marks, but I am writing M. Right? Right. Now let me go to the third. M dot sort. M dot sort. Print 3 comma M. Print 4 comma ID of M. Next one. M dot append 755. M dot append 595. Print 5 comma marks. Marks in the sense M. Yeah. Bhaiya 5 comma M. Next one. Print 6 comma ID of M. Next M dot reverse print 7 comma M. Print 8 comma ID of M. Yeah, fine, perfect. Till now perfect. Can you go to next? 8 is over. Next one. M dot sort. Reverse is equal to true. Print 9 comma M. Print 10 comma ID of M. Next one. I think one more line is pending. One more line. Maybe I will go further. I tried my level best. I will go further where I can write. Yeah, I can write the 11. One more, few more statements are there. They are also required. Let me write. Here I am writing. Print. So I think last one is, I think 10th one. No? Yeah. Let me go to another line. Small modification. Small modification. M dot inset. M dot inset 0 comma 600. Next print print right, print 11 comma m. Next one print 12 comma idea of m. This is the problem. Can you go ahead? What is the answer you are going to give? What is the answer you are going to give? Can you go ahead? Can you go ahead? One by one line go. One by one line go. Whatever you know, you right, those only small changes are there. Whatever you know, those only small changes. For your convenience, everything I printed. For your convenience, everything I printed. It is the 0th place, first place, second place, third place, fourth place, fifth place, sixth place, seventh place, eighth place. Can you go ahead? Be careful, everyone careful. Right, first one, as usual. First one, print m. So all will be printed. Print m, all will be printed. 87, 64, 33, 95, 7, 6, 78, 80, 68. All will be printed, nothing special. So first one is completed. First one, no one having any problem. First one, no one having any problem. Let me minimize a little bit. Let me minimize. Yeah, I done also. Yeah, fine. So first printf is completed. See everyone, first printf completed. See the second one. Everyone observe second one. Print id. Id means some address. So as usual, I think I assume that address of this list is 1000. Address of this list is 1000. Try to understand. Everyone try to understand. Till now, no one having any objection. Afterwards, m dot sort. I think it will do sorting. It will do m dot sort, right? Afterwards, it will do m dot sort. Sorting is done, right? Sorting is done. That's okay. Sorting is done. That's fine, right? And by default, ascending order. By default, sorting means ascending order. Now, afterwards, what I done is, right, in the third line, if you see, I printed. Third line, if I see, I printed. So remember, when you printed third line, ascending order will be printed. Let me see ascending order. What is the ascending order? 6 will be there, 7 will be there. I think 8 not there. I think after 7, after 6 is 7. I think what is the next one? 33. Check one, 33. Afterwards 64. Afterwards 68. Simply sorting. 68. Afterwards 78. Afterwards 80. 87. 95. Just sorting. And for your convenience, after sorting I printed. After sorting, I printed the address also. Just to know, is it in place or out place? Because of same elements only, right? Same elements only, right? So within the array, same elements only. There is no requirement of additional space also. If you see, same address will be printed. Remember, right? List is a mutable one. Within that you can change it. So there is no requirement of additional space. Within that you can sort. There is no issue at all. I think fourth one also completed. Let's go to fifth one. Right? I think after fourth one I done some changes. You know very well. Append means lastly added. So two appends are done. So whatever is the recent list is there, to that recent list. It is a recent list assume. What is the recent list? It will start from 6 because you are already done sorting. 6 to 7 and so on. Last one I think as of now 95. Afterwards 755 will be there. 595 will be there. Right? So this is, but anyhow is not printing debit. So here it will print. So this is printed. This is printed. So printf 5 is everything same. Lastly, two people will be added 755, 595 because it is a append function. This is also completed. Append function it is, so we done it. Now let's go to print 6. What is the address? You know very well. Append function. Yesterday we done remove function. Right? They are in place. You know very well. Right? You know very well. Same address only printed. If you want, you can verify. Yesterday itself we done. After every small change, I printed two things. List also I printed, address also I printed, so that you will get to know what is happening. So that you will get to know what is happening, right? I think until sixth point, no one having any doubt. Anyone having any doubt, let me know. Sir, sixth point, I am okay. Until sixth point, I am okay. Let me know. Ready, sir? I am perfect. Until sixth point, I am perfect. Please let me know. Hello. Until sixth point, are you okay? For your convenience, after every small change, I printed the list also, I printed the address also. Next to reverse. Reverse means it will do reverse. Reverse means it will do reverse. If you want, you can print also. When you print, what happened is, whatever you have, it will reverse it. What you have? 595, 755, whatever you have, reverse. 95 and so on, 7 and 6. This also complete. Right, till now 7 also completed. Let's go to 8. Let's go to 8. I think after reverse, what is the answer? Within that, just reversing, right? Same address will be printed. If you want, you can verify. If you want, you can verify. I think it is the 8th statement, right? One, right? Same address. Same address. 1000 only printed. If you want, you can verify. Because of it is mutable. List is mutable. Everything will be done inside only. Everything will be done inside only because it is immutable. That is the reason for this. Next one, do sort. Right, do the sort. See everyone now. Normally m dot sort means sorting will be done, that's okay. But reverse is equal to true means you have to sort in the descending order. Actually sort means ascending order. Ascending order. Now m dot sort reverse is equal to true, descending order, right? Descending order. So let me write now. Descending order. M dot sort reverse is equal to true, descending order. Descending order will be printed. So descending order means what? Whatever you have, whatever elements you have, remember, whatever elements you have, descending order from big number onwards it will print. So this is the right descending order. Anyhow, in the next line printing only, I will print now. So let me print the descending order 9th statement. First to 755 will be printed, bigger number, right? Bigger number 755. Next one 595 will be printed, right? Afterwards 95 will be printed. So and so on it is going, and so on it is going. Lastly 76 will be printed. Yeah, parrots are doing a lot of nonsense. Parrots are doing nonsense. Hello parrot, if you want to listen Python, you will listen. You want to learn Python, no? Learn, right? Don't do sound. Little see, I like your sound doesn't mean that every minute you will do like this. If you do like that, most probably I will close the door. Let me close the door. Let me close the door because they are doing a lot of sound. Let me close the door. Yeah, I think so. Ninth one is fine. Ninth one is descending order, nothing. Go to the 10th one. Address you see. If you see the address, same address will be printed, nothing will change. Nothing will change. Right? I think 10th line also completed. Can you go to? Everyone be careful. Can you go to after 10th statement? Can you go to next? I think this one. Inside is one. Inside 0600. What it means? So remember in the M, whatever list you have now, as of now, 0th place inside 600. That is the meaning of this 0th place. Actually, as of now, 0th place who is there? As of now, 0th place 755 there. That place you are storing 600. That place you are storing 600. Now, if you see the resultant answer, I think first place itself 600 is there. First place itself 600 is there. 0th place you are inserting 655. So previously who is there? 755. Previously you have 755. And one more thing, remember, insert. You are inserting 0th place, right? You are inserting 0th place 600. So if you do that, if you observe clearly, one more element will increase. It's not modifying, it's inserting. When you insert 0th place 600, all people will shift one position right. All people will shift one position right. That means, remember, it is not a modification, it is an insertion. 0th place you will keep 600, remaining all people will shift. So 600 here, afterwards 755, afterwards 595, and so on, all will come. Remember, 0th place you kept 600. It doesn't mean that, right, already 755 is there, you will overwrite. It's a very, very important point. Please remember. Please remember. 0th place, right? I will write here. 0th position, 600 inserted. 0th place, 600 inserted. Right? Remaining all one position, right? Remaining elements. Existing elements, one position, right shift will be done. One position or one right shift, right hand side shift will be done. RHS or RS, right shift. 0th place 600 is inserted. Existing elements, right, one right shift will be done. One right shift. All will go one position right. Because of it, simply insertion only. You don't need some extra space, right? Only one slot is okay. I think same address will be printed 1000. It's a very, very important one, right? I think this one you can learn in this problem, something new. I am underlining also. This one you can learn. What exactly insert will do? For insert, you have to give position also, element also. For insert, you have to give at which index, which element you want to insert. It doesn't mean that you are modifying. It means one right shift is going on. Please verify. Please verify one right shift is going on. Please verify one right shift is going on. Let me know anyone having any objection. So for your convenience, I will execute also one. Can you see this one time? For your convenience, I am executing also once. See this one time. See one time. What is happening here? You can check once. What is happening here? You can check once. I'm just checking. Assume that m is equal to 10, 20, 30, 40, 50. Assume it is a m. Okay, fine. And one more. Yeah, perfect. So if you want, I can increase a little bit so that you can see. Yeah, now it's perfect. M is equal to this. See this next one. Print m for your convenience. Print m, that's okay. It will print it. Now what I'm doing is m dot insert 0th place 77. That is one thing I done. Afterwards, print m. For your convenience, I'm doing. Afterwards, what I'm doing is again m dot inset uh, third place inset 300. See what is happening. See what is happening. You will get the clarity. Print m. Little doubt there. Execute the program. You have little doubt. Execute the program. Let me run it. If you run it properly, if you run, see sir, if you run it properly, let me check. Run. Yeah, I'm just checking. See this. If you run it properly, first printf. For your convenience, that is the reason I used to give numbers also. 1 comma. It is 2 comma. 2 printfs, no? 2 comma. Is the third printf. 3 comma for our convenience. So that you can check carefully. Now see what happening. Now see what happening. In the one, actual list is there. Please see. In the one, actual list is there. In the two, if you observe, 0th place I inserted 77, remaining all shifted. But if you observe clearly on the right hand side, observe clearly one thing on the right hand side, see, it's increasing. Means every insertion, one right shift is going on. Every insertion, one right shift is going on. If you want, you can check 0th place previously 10 there. Now I kept 77. It doesn't mean that 10 you are losing. Right? Just one right shift is going on. Now see what happening. In the third place, I kept 300. So third place, see, 0th place, first place, second place, third place. See, third place actually 30 there. I kept 300. It doesn't mean that 30 will go. 30 is going on the right hand side. See, one right shift. Whichever index you are inserting that element, so you need gap first. So what they will do is they will do one right shift from that position onwards. All elements one right shift will be done so that that place gap will come. In that gap they will insert the element. In that gap they will insert the element. I hope you got. Little doubt there, you execute like this. Little doubt is there, you execute like this. Okay, fine. I think everyone is comfortable. Okay, fine. Fifth one is completed. In this problem, please learn insert. Some people are asking, sir, yesterday, insertion purpose, you done append, na? Yeah, append will insert at the end. See, append function don't have index. Append function don't have index. By default, it will insert at the end. But insert function having index. Wherever you want, you can insert. Wherever you want, you can insert. But it doesn't mean that the existing element you lose. It will go to right shift. It will go to right shift. So let me write one small story here. Insert function. Insert function will take two parameters. Position means index. Index and value. It will take two things. Index and value. At which index you want to insert and what you want to keep. But remember existing element at I, existing element at I will go right hand side by one position. Insert, right? Insert index and value. Existing element at ith index will go right hand side by one position. You don't lose it. Existing element you don't lose. Existing element we don't lose. Existing element we don't lose. Great teaching, sir. Hi. This is RBR. Hi, Ravi. Thank you so much. It's getting compliment, getting message from you is a really blessing to me. Thank you so much. So this is This problem is, be careful everyone. Right, this is the answer for this. Insert I comma b. Existing element at I will go to right hand side by one position. So remember, existing element we don't lose. Because of insertion, we don't lose the existing element. You are a great teacher, Ravi. Ravi, you are a very great teacher. You are an inspiration to many people. You are inspiration to many people. Keep doing great for the students as usual. What you are doing. Thank you so much. Thank you. Right. So these are the problems what we done yesterday. Yesterday, these are the things what we done. So this is the one problem of list. This is another problem of list. This is another problem of list. Let me know anyone having any issue. Let me know if anyone having any issue in this problem. Right? New point in this problem is insert only. Insert is the new point. Remaining all normal. Remaining all are normal. Only insert is the new one. People will think that it will modify. Sir, some people are asking, sir, I want to insert in the list. I want to insert wherever I want. In the list, I want to insert whichever position I want. Can I do that? Yes, you can do. How? Using insert function. What you have to provide? Index and value. So if at all, sir, if I do that, at that place, someone already there. What will happen? One right shift will happen, so that at ith place gap will come. In that gap, you can insert your element. In that gap, you can insert your element. Right? Fine. Perfect. Yeah. Let me go to. All right. Few minutes. I want to say about EPT stuff. It may be useful for the new people. Right? Yeah, see this one. In the EPT GATE 2026, these are our rankers. Aman, Razu, these are our students who got the very good rank. Some people use the free resources, some people use the paid resources, but these are our students who got the top rank. The interesting thing is, most of the people done, right, within 6 to 12 months. There is no requirement of writing the GATE examination 2 years, 3 years. Most of the students we have visible on the screen, they done, right? Approximately 6 to 12 months they completed the GATE. They got the very good rank, right? So you also, those people who are watching this, you also to crack the GATE examination, right? 6 to 12 months are more than enough. I request you, please start. If you are a EPT student, if you are liking EPT classes, you can refer to your friends. You will get the 20% cashback. And right, so remember everyone, 30th April, right? 30th April, I think 2 days back, one batch is started. Some orientation class is going on now. Just introduction classes are going on. I request everyone, you can join in this batch. Right, DLD subject is going on. DLD, Digital Logic Design, is going to start today. Right, so the teacher is having approximately 20 years of experience. He taught approximately, I can say 500 batches. He taught so many batches. Right, DLD subject is going on today. Right, at 8 p.m. At 8 p.m. in the EPT platform, it is going on. At 8 p.m. Right, EPT platform, it is going on. 500 batches he taught. So it will be going to be very useful. So please take care. And one more thing is 70% discount going on. You can utilize. And if you selected to any company interview, so we are going to conduct a mock interview. Please inform to us. We are going to conduct a mock interview with the experts. These are EPT faculty. So total C programming is free. The EPT platform on YouTube, you will find out total C programming is free. You can utilize. Total C programming is free. You can utilize. And IIT Hyderabad exam. I hope you utilized all the mock tests. So bits, right, in the place of this, see this one. Bits mock test is going on. Please utilize. So these are the EPT courses, right? You can, if you want all, go for the EPT combo course. If you want gate and placement, go to the gate plus placement combo course. Gate regular course, you can go. Gate foundation course, you can go. Test series, you can go. Mentorship program, you can go. Gate plus top PSU course, you can go. Whatever you want, you can select. Right. Every weekend there is a mentorship session. Every weekend there is a mentorship session. We are going to give, right, weekly target, monthly target, so that you don't miss, right, gate examination in the first attempt. Our goal is getting the gate rank in the first attempt only. Our goal is very clear, getting the gate rank in the first attempt only. First attempt only. So we are going to do every weekend. We are going to guide, right? What are the subjects you have to study in this week? What is the monthly target? What is the 3 months target? Everything we are going to provide. I request everyone, don't miss it. So these are our free resources you can utilize. You can utilize all these free resources. Why EPT, right? Recorded plus live classes. Daily quizzes are there. Quick doubt solving is there, right? Gate and verify, right? Gate PYQs and verified questions, right? So many, approximately I can say 5,000 verified questions are there with PYQs, right? These are more than enough to crack the gate examination. Next one is going to be, right, we will give the mentorship every weekend, and right, placements also along with that, right? We have the right proper strategy to crack the gate examination. These are our students who placed in the, right, our placement course plus gate. Some people are placement and gate, some people are only gate, some people are placement and gate, some people are only placement. If you want only placement, you can take this course. Yeah. Thanks. DSA Super 50 going on, you can utilize this, where 50 best interview questions will be given to you. Right. Now come to the next. Come to the next now. Now everyone listen, next problem. In the previous problem, what is important, we are already discussed. Right? Let's come to next problem. In this problem, you will see something else. Let's check. In this problem, you will see something else. Let's check here. M is equal to, in this problem, you are going to see something else. Please check. M is equal to 87, 64, 33, 95, 7, 64, I think 2 times 64, yeah, 78, 80, 68. Next one, print 1 comma M. Next one, print. So first one is print 1 comma M. Second one is, as usual, I am printing 2 comma ID of N. Till now perfect. Next one, M dot. Next one, M dot remove. Remember it is a remove function. Previously insert, now remove. 64. Right? That is fine. 64. I think yesterday we done append function, remove function. Yesterday we done append function also, remove function also we done. Right? I'm reminding you once again. Right? Now next one. I think M dot remove, afterwards as usual print. 3 comma M. Print 4 comma ID of M. Okay, that is as usual, you know very well. Now come here, new point here. M dot pop 5. M dot pop 5. What it is exactly, you will see. Right, next one. Can you see some? Print 5M. As usual, print 6 comma ID of M. So this is the problem. Anything new there in this problem, please learn. Anything new there in this problem, please learn. M is equal to this. Print 1 comma M, print 2 comma ID comma M, M dot remove, print 3 comma M, print 4 comma ID of M, m dot pop of 5, print 5 comma m, print 6 comma id of m. Yeah, this is the problem. Now what you do is, let's see one by one what is the answer. In this problem, what you can learn, let's check. Yeah, as usual, I think this is the m, fine, perfect. So print it as it is printed. As you, whatever there as it is I printed. Whatever is there as it is I printed. I am not done any change. I am not done any change. Let's come to second id. Some address will be printed, assume 1000. Because of list is mutable, na, mostly same address will be printed until unless there is a big space required. Like in the yesterday's class we discussed, right? A double list into 2, double of the list into 5, right? 5 times of list, then more space required, then automatically it will go to outside, it will create, it will take one more object of that much space and it will create. But most of the time, because of list is mutable, it will create inside only. Right? Now next one, remove. In the last class itself we done remove 64. Wherever first time 64 is there, it will remove it. So what the answer? 87. I think 64 is gone, right? 33, 95, 7, 64, 78, 80, 68. This will be gone. This will be gone. That's fine. So that's what printf, when you print it, it will print. Now address, I think no change there, 1000. Until now nothing new. Until now nothing is new. Now understand. Until now nothing is new. Now understand. New thing. New thing here. See this one. In every problem, I want to say something new. In every problem, I want to say something new. Every problem, I want to say something new. So in this problem, what is the new here? See this one. M dot pop of 5. Remember, pop of 5. Remove pop look like same. It is a remove element. Remove 64 element. Remove 64. First occurrence. First occurrence. So many times it is there. Right? First occurrence you have to remove. Remove 64. 64 removing first occurrence. Okay, fine. But what the pop 5 will do? What is the pop 5 will do? Very simple. Pop 5. See this one? 0th place, first place, second place, because it's already deleted. 0th place, first place, second place, third place, fourth place, fifth place. It is the fifth place. Fifth place element you can delete. Fifth place element you can delete. Let's see the expected output. 87, 33, 50, right? If you want, yeah, 87, 33, 95, 7, 64, 78 is gone, 80, 68. Now it's going to be 0, 1, 2, 3, 4, 5, 6. In the modified list, this is the story. Print ID, I think because if you are deleting one element, no change in that. Please let me know. Remember, pop 5 means it is an index. It's the index. Index, fifth index element delete. That means fifth index element delete. But when you delete, no, automatically the elements which are there on the right hand side, they will come one position back. I think almost like left shift will happen. Almost like left shift will be happen. Pop, na? I think what is the printf statement? 5. If you see the printf statement 5, 87, 33, 95, 7, 64, 80, 68. Exactly. Right? Same index. Right? A pop function, na, you have to give index. Pop function, you have to give index. Remove, you have to give element. Pop and remove look like same. Right? Pop and remove, right? See this one. Pop, you have to give index. Right? Let's see, someone is knocking the door. What exactly they want to say? Let's see. Just give me 1 minute. So remember, pop I, remove, remove, remove element. Here index. Pop function will take index. Remove will take element. So what they will do? They both will delete. Pop also will delete, both will delete. Both will delete. It will also delete. It will also delete. Both will delete. Right? Pop will delete and remove also will delete. Both will delete. But it will delete. Assume that index 5. Fifth index element. And in that place, right, fifth index element you deleted. In that place, all right elements, one left shift will be happen. Here most probably we will see left shift. Fifth index element deleted. Then in that gap, all the people who are there on the right hand side, right, all the elements which are there on the right hand side, they will do one left shift, almost like this. If you see the remove element. So it will also delete, right, first occurrence of element. Let us assume that it is 64. First occurrence of 64 will be deleted. And in that place, the elements which are there on the right hand side, they will do left shift. Here also see, left shift will happen. Deletion means left shift. Insertion means right shift. Now see the insertion purpose, two more people are there. One is append. Append function will take, assume, right, append function will take element only. Assume that you are given 500. So it will insert. Where? At the end. 500 will be added at the end. Right? Next one. Append is fine. One more thing we see in today, insert. Insert function. Insert. Right? Here you have to give position also, means index also, value also, element also. Position and element. It will insert. But let us assume that position is 5. Element is 300. What it will do? Right? What it will do? At fifth position, 300 will be added. And one more thing is 300 will be. What about existing element? One right shift element, right? One right shift will be done. Existing element, right shift. Existing elements, right shift. At fifth position, 300 will be added. Existing element, one right shift will be done. Yeah, perfect. I'm thinking that everyone is perfect here. Let me know if anyone having any doubt till now. Till now, do you have any doubt? These are very, very important, right? You may be confused also. That is the reason I written specially. These are very, very important. In the examination, they will play these only. So my request to all the people, these are very, very important. Before going to the exam, check one time. These are very, very important. You will confuse. The only problem with the Python is so many functions are there. So many. You will confuse if you don't do practice. So many functions, not one function, two functions. So many functions are there. So please, my request, everyone is do practice. Yeah, I think you are perfect. Remove, one is deletion purpose, pop and remove. Look like same. Both will delete, of course. But right, if you observe, one person is index, one person is value. But append function, right? Value and one more thing is position and value. So there is a small difference is there. Please take care. Now let's come to next problem. Let's come to next problem. There is some change there. Let me go ahead. In the next problem, you will see something else. In the next problem, you will see something else. Let's see this. It is also interesting problem. It's a very small, but it's very interesting problem. Let's see. L1 is equal to 1, 2, 13, 3, 2, 1, 1. L2 is equal to L1. Next one, print 1 comma L1. Next one, print 2 comma L2. Next one, be careful everyone, be careful everyone, L1, L2, everything is fine, L1, L2, everything is fine, right? Let me check one more thing, let me check one more thing. So, print 3 comma ID of L1, print 4 comma ID of L2, right? Next one, let's see one more interesting thing, L2 dot reverse, reverse will do reverse, please be careful. Next one, print 5 comma L1, print 6 comma L2. Right? This is a problem. Right? Please check one by one. Please check one by one what will be the answer. What will be the answer? Please verify. Please make sure everyone try this. Please make sure everyone try this. Everyone try this. What will be the output? Everyone have to try this. Everyone should try this. This problem, what is the answer? Right? When you do this now, when you do like this, L1 will be created. Let me use another color. L1 will be created. Fine. L1 will be created. L2 is equal to L1. So remember, because of same, what happened is both will point to same. Both will point to same. So I want to say here, his address is 1000. His address also 1000. It is a copy. Simply copy. Simply copy. As it is, no change at all. Because of same, you know very well. Because of same, right? Both will point to same place. Because of same, both will point to same place. L1, L2 point to same place. So if you see the output, same thing will be printed. Same thing will be printed. Right? Next one, you done the reverse, L2 reverse you done. Okay, reverse happened, that's fine. Now when you print it L1, all the reverse will happen. All the reverse will happen, right? Because both are same. 11, 2, 3, 13, 2, 1. This is also same. Same will be printed. Let me know. Let me know if anyone having any issue. right? I hope you are fine. So remember, it's a simply copy, nothing special. So both point to same, both are sharing same space, both sharing same space. One modify, other also will modify, other also modify, one modify, other also modify, one modify, other also will modify, both sharing same space, both sharing same space, one modify, other also modify. Next one, next one, both will print same address, just copy, that's it, just replica, just replica, both contain same address. Both contain same address. Okay, I think L1 done, L2 done. Now see the printfs also done till now. Right, reverse, I think after reverse both will update. So what I want to say in this problem is, what I want to say to both of you, all the people is, right, it is a simply copy. Because of same data, copy. No change also. No change also. Just copy. And one more, because of it is a mutable, little changes also there. Because of it is a mutable, most of the things you can edit inside only. Sorting also inside only, reverse also inside only. Most of the things are inside. But until unless you really say, I want one more different copy, it may not create different copy because of it is mutable. And one more, same data, exactly same copy. Same data, exactly same copy. Right? Please be careful. Please be careful. Now I will say, right? I will say one important thing, right? With the help of this new problem, I want to bring one new story to you. One new story to you with the help of this problem. Please listen, everyone. Please listen, everyone. Everyone listen. With the help of this problem, I am bringing one new story to you. One new story I am bringing, so please listen. Listen, everyone. Listen, everyone. Just one, right? Just listen one small thing. Just listen one small thing. Yeah. You have to write one line first to write series. Import. Import copy. Copy. Copy function you are importing. Okay, that is fine because this is something related to copy. Import function copy. Right? In the code also you write import copy first. Afterwards, what you do is see this one. List 1 is equal to 1, 2, 3, 4, 5. Careful. List 1 is equal to 1, 2, 3, 4, 5. Next one, list 2 is equal to, careful, what will happen? List 2 is equal to, understand, list 2 is equal to list 1 copy. Just you are using copy. List 1 is equal to, so list 2 is equal to list 1 copy. List 1 copy, you are using copy function. Understand here, you are using copy function. Right? Make sure everyone, you are using copy function. Okay, you done the copy function. Okay. Let me write once. Yeah, different ways of writing is there. So like this you done. Import copy, L1 is equal to 1, 2, 3, 4, 5. L2 is equal to L1 dot copy. Then when you do this, right? When you do this, please understand one time. When you do this, just I am writing here. See this one. Print 1 comma L1. Print 2 comma L2. So when you see the data, both will print same content because it is a copy. Because of it is a copy, both will print same data. 1, 2, 3, 4, 5. Exactly same data they will print. No change at all. No change at all. But interesting thing is, everyone understand. But interesting thing is, when you say print 3 comma 3 comma idea of L1 print idea of L2. When you do this, what happened is they both are copy, okay, right? L1 copy is L2. L1 copy is L2. Let's see this one. L1 copy is L2. Okay, that is fine. Both are copy, right? L2 is the copy of L1. That's okay. But interesting thing is, this is printed 1000. This will print 2000. They both are different. If you want, this is called the story what I am discussing. That is called as, right? Maybe I may say one more example here. So I am maintaining some space. This story is called as, right? I am writing the keyword also. Don't forget the keyboard. I am writing that keyword also. That keyword name is called as copying only, right? I am writing shallow copy. Shallow. This is called shallow copy. Shallow copy, whatever it is. Shallow copy. Right? So means copy only, but interesting thing is one more is created. Remember, L1 is L1 is copy of L2. Instead of saying, you can say L1 is shallow copy of L2. L1 is shallow copy of L2. Or L2 is shallow copy of L1. Right? That means they both are independent. Copy only, but independent. Some people are asking, then what is the effect? Can you see the effect here? What is the effect? Please try to understand. Because of they are independent, there is some issue. See what will happen. See what is the interesting thing, what will happen. Can you see this one? List one of 1 is equal to 4. So what is the meaning? In the list 1, 0th place, first place, second place, third place, fourth place. 0th place, first place, second place, third place, fourth place. In the list 1, careful everyone. List 1, 1th place, 2 there. As of now, 2 there. You replace by 4. This is 2. You replace by 4. Okay, I done. Now afterwards you do print L1. Print L1. Next one is print 6 comma L2. Right? If you do this, what happened? It will print 1, 4, 3, 4, 5. That is the one thing. It will print one more thing. If you observe. It will print 1, 2, 3, 4, 5. See, because of their independent copies, they don't affect. One changed, other one don't change. One change, other one don't change. Please be careful. One change, other one will not change. That is the meaning of shallow copy. So there is a difference between, if you don't write anything, simply if you write L1 is equal to L2 or L2 is equal to L1, exact copy. See this one. Copy only, both sharing same space. If you do like this, both sharing same space. You want copy, but what kind of copy you want? You want exact copy, exact thing you want? Then I think you have to go like this. Then what is the problem? One changes, other will change. One changes, other will change. But if you want copy, but shallow copy, what is the meaning? Content. If I change one person, other person cannot change. If I change one person, other person cannot change. Right? In Python, this kind of facility available. You want as it is copy. One changes, other one also will change. If you want like that, go like this. If you want shallow copy, like this. But shallow copy is not deep copy. Remember, it is not deep copy. It is not deep copy, shallow copy only. Means there are some issues. What is that? Let's check. Let's check. I'm writing the same story one more way. See this one. Import copy. Okay. Now see this one. Import copy. That is fine. Now see the answer. L1 is equal to, carefully everyone. L1 is equal to 1 to 1 to something. If you want, I will write that also. Let's check. It's better to copy, otherwise some misleading will happen. So I'm writing here 1 2 in the place of 1 to some number 1 7. See this one, list now. Inside list every element can be list also. You need not write. See, list is, if you observe clearly, different types you can store. Inside list elements need not be homogeneous. They are heterogeneous. Means you can keep different types also, no objection at all. 1 7 I kept, 3 5 also I kept. But remember, 3 5 is one element, 8. Now see this one. L2 is equal to L1 copy. You done like this. L2 is equal to L1 copy. You done. Now see the answer. Print 1 L1. Okay. Print 2 L2. That is also okay. Next one. Print ID of L1. Print ID of L2. That's okay. Normal thing. So same will be printed. Until now, no change. Until now, no change. So if you do this, right, it will print as it is 1 7 3 5 8. It is also same printed. Its address is 1000. It is 2000. You know very well. They are independent copies. Copy only, independent. Copy only, but independent. You see the data same, but they are different places. But see the problem. See the problem, because of this important one, I'm changing the color also. See this one, I'm changing the color also. I'm changing color. So what is the meaning here? They are independent copies. What is the meaning? One changes, other one will not change. One changed, other one will not change. But the problem here is, this is shallow copy only. I'm writing here. I'm writing somewhere here. Somewhere I'm writing. Let's check. Somewhere. Remember, it is shallow copy. But shallow copy is not deep copy. It is not deep copy. It is a shallow copy. What it is? See this one. What it is? In the L1 list, if you go, it is 0th place, first place. 0th place, first place. It is the second place. It is the third place. In the second place, it is the 0th place, first place. 0th place, first place, second place, third place. In the second place, there is a 0 also, there is a 1 also. There is a 0 also, there is a 1 also. Now see what happened. L1, see this one, L1 of 2. L1 of 2 means this one will come. L1 of 0, L1 of 1, L1 of 2, L1 of 3, and so on. L1 of 2 means, I think this will come in that 0th element. So this will select it. It's something like 2D array. Inside list, again list, 2D array. Inside list, again list, that is called 2D array. So in the L1 second element, inside that 0th element, I think 3. Right? It is a 3. Remember, it is a 3. 3 place, actually it is 3. It is 3 actually. In the 3 place, I am keeping 97. I am keeping. So then what happened is, see this one, this is the 3. In this place, I am keeping 97. Yes, I kept. Now what happened is, observe here. Print 5L1, print it. Print 6L2. When you do this, what happened is, see this one, what happened is, L1 updated, L1 updated, see this one, it is the 1, it is 7, right? It is the list to year 97, year 5, year 8. It is updated because of you changed it. It is updated. Because of you changed it. It is updated. Okay, fine. Now see this. Now see this one. 1, 7. L2 is not updated. Remember, L2 is not updated. But what problem is? 97, he will also update. Even you are not changed him, but still he will change. Sir, they are independent copy. Now, how they will change? Remember, it is shallow copy. It's almost like intermediate copy. This person, see this one, this person, first problem, whatever we written, this problem, exact copy. One changes, other will change. One changes, other will change because they both are sharing same memory. But here, if you see the shallow copy, now they both are not sharing same memory. They both are sharing different memory. Right? And one more thing is, first one changes, second one will not change. First one, see this one, first one changes. First one changes, second one will not change. Because they are independent copies. But remember, if nested lists are there, this shallow copy will not work that much deeply. First level, it look like working. First one changes, second one not changing. First level, but second level, it don't work. See, second level, I change it to the second level. I change it to second. What is the meaning of second level? Inside list, again list. In second level, I change it 3 to 97. Then he will also change because it is not deep copy. It is a shallow copy. Shallow copy means partially independent. It look like independent, partially independent. If you want fully independent, if you want completely independent, you have to go to the right deep copy. You have to go to deep copy. So I will write one example for a deep copy also. Deep copy means what? First level also. If one changes, other will not change. Second level also. One change, other will not change. Third level also. One change, other will not change. If you want a completely independent copy, deep copy. If you want intermediately independent copy, shallow copy. If you want copy, but exactly same, normal assignment. Right? I will go to deep copy. One example I already given, right? So deep copy, I will continue this. So how to write the deep copy? I will give one example. Can you see this one? Example. Say you write import. Import copy first. Okay. First do import copy. Next one, what you do is some m is equal to. Some m is equal to. Can you see this? M is equal to 1, 2, 3, comma 4, 5, 6. See what the deep copy saying. M is this. Now what I am doing is, careful everyone. L2 is equal to, see how to create the deep copy. L2 is equal to, you can write like this. L2 is equal to, right? L1 dot. L2 is equal to, wait. L2 is equal to L1 dot copy place a deep copy. Okay. Syntax. This is the syntax. L1 dot deep copy. L1 dot deep copy. L2 is equal to L1 dot deep copy. When you write this, or this one, you can write one more way. This also okay. You can write like this also. How? Copy dot deep copy. L1, you can write like this also. Copy dot deep copy. Simply deep keyword required. Copy required, deep also required. Deep copy. Right? You can write L1 dot. So you can keep empty here. L1 dot deep copy you can write, or copy dot deep copy L1. You can write whatever way you want. Then what happened is both are independent. First level also independent. Second level also, everywhere independent. When you say deeply they are independent. Means everywhere they are different. Now let's check. Print 1 L1, print 1 L2, sorry 2 L2, that's okay. Addresses, if you want, you can print 3 ID of L1, ID of L2, ID of L1, ID of L2. I'm printing both at a time. Now let me do change. L1 of, it is the 0th element, it is the first element. Inside 0th element, first element, second element. 0th element, first element, second element. Now see, L1 of 1 inside that 2. L1 of 1 means this one will come. Inside the 2. 2 means this one. 6 will come. This is 6. Is replaced by 99. I replaced that one by 99. Now see what happened. Print, I think number 4, L1. Print 5, L2. When you see this, what happened is 1, 2, 3. Okay. Now 4, 5, 6. 4 place I kept 99. No? Sorry, 6 place I kept 99. 4, 5, 99. It will print. Okay. But if you observe clearly, because of it is a deep, it is a deep. So what happened is it's a 1, 2, 3. It is 4, 5, 6 only will be printed. It's a deep. It is a deep. It is the deep. So this is a very, very important. So remember, deep copy is very simple. You will find out deep keyword. Right? So whether you write L1 here or L1 here, you decide yourself. 2 ways. Like this also. But remember, deep is there. Deep is there. Copy dot deep copy of L1 or L1 dot deep copy. Right? You can write one program and you can verify also. Deep is there means, oh, they are entirely different. Every manner they are different. Shallow copy. Shallow copy, how to identify? Shallow copy, how do you identify? There is a copy keyword. There is a copy keyword in the shallow copy. Right? I think different ways of shallow copy I will write here. Different ways of writing shallow copy. Deep copy is very simple. Deep is there. Deep is there, deep copy. Right? Shallow copy, different ways. Many ways are there. I will write once. Shallow copy, different ways. So one way is very simplest way. Very simplest way. Let me go here. One very simplest way. L1, right? L2 is equal to, very simplest way I am saying. L2 is equal to copy dot copy of L1. That is one way. So you will see copy keyword. 2 times also you will see copy dot copy. Or one more way of saying the same thing is L2 is equal to, we written already, L1 dot copy. That is also same. That is also one more model. But remember, copy is there. Here also copy is there. One more thing interesting, see this one. L2 is equal to, see this one, L2 is equal to L1 there, but no copy, nothing. So like this. Everything from starting to everything from ending, simply copy. This is also shallow copy. You please check one time. Addresses will be different. You verify. This is also shallow copy. Different ways of writing. And one more thing. L2 is equal to, see this one, list of, because it is a list, no? List of L1. This is also. If anyone having any doubt, these are all the things you write in the system, you can execute once. If anything is wrong, let me know. I studied somewhere, these all are same. These all are shallow copy, right? Different ways of doing. Shallow copy, different ways of doing. One more thing. L2 is equal to different ways of doing. I think you may be confused. Afterwards, we will see this. These are the things. Shallow copy, different things. Shallow copy means copy keyword is there. Without copy keyword also possible, so like this. Without copy keyword also possible, like this. However, please verify one time. If anything wrong, let me know. So addresses should be different. And one more, first level, it look like independent, but second level may not work independent. Second level don't work. First level it will shallow copy. First level it will look like independent. Second level, I think changes are going on. Second level, if I do any change, all are effective. But in the case of the deep copy, in the place of deep copy, remember, deep copy is very simple. Simply deep keyword is there. Deep copy is very simple. Simply deep keyword is there. Simply deep keyword. Here copy keywords. Here also copy there. Here also copy there. Here also copy. But here deep copy. Here simply copy. If no copy, nothing. If no copy, nothing. Like this. Like this. If no copy, nothing is like this. No keyword of copy. But exactly, it's the easiest way of doing. L2 is equal to L. I want to copy here. L2 is equal to L1. But side effect, both will share same memory. One will update, other one will affect. And both are same address, everything same. Right? Now, if you want different address, right? And one more thing, one affected, other one will not affect, at least in the first level. Let's go to shallow copy. At least first level, see, first level, no problem. But second level, there may be a problem. If you don't want second level also problem, right, you can go to the deep copy. Deep copy will take care about everywhere different ways of doing shallow copy like this. However, you will execute. Somewhere I seen, I just kept it. I think I verified also. You also verified. Shallow copy, different ways of doing. I verified. I request everyone. Without verification, normally I don't do. Without verification, I don't do normally. I request you anyhow. You also check. Create the different copies like this. Find the right. So print the copy. Right. Both print the both the addresses and change, and you check one by one. I verified all the problems. Without verification, normally I don't. Right. I think we done excellent class today. So in the tomorrow's class, we'll see with some more details. Tomorrow's class, we'll see some more details. I hope everyone got it. I hope everyone got it. This is a very, very important thing. This is a very, from where copy started here. Copy. See this one. Copy. Shallow copy. Deep copy. Careful. This is a very, very important one. When you are solving the problem, you will find out a lot of difficulties when you don't know this. When you don't know this, you will find out a lot of difficulty. Some people are asking, sir, this is copy, shallow copy, and deep copy. Is it only for list? No. This is for all mutable things. All mutable data structures are types. This concept is valid. Unmutable means you cannot change. There is no concept of copy. Whenever it is unmutable, whenever there is a meaning of, whenever there is an unmutable, you cannot do any change there. We don't need to discuss about this copy for unmutable, only for mutable. For all mutable types, this concept is there. Not only list, all mutable. List is mutable. Okay. Dictionary also, which will come further afterwards. Dictionary also, and so on. I cannot say more here. I already said many times. I will write further also. List to dictionary, something like that. List is mutable. All mutable types having this concept. All mutable types have this concept. Or all mutable types, this concept is valid. Fine. Thanks everyone. See you in the today's mentorship session. See you in today's mentorship session. Thank you so much, and yeah, bye.